Okay. All right, so right here, my sine is the y value. How much did I go up? That's radical 2 over 2. It's just the y value. That's the sine of 45 degrees. How about the sine at pi over 3? It's radical 3 over 2. And then I just said this, the sine of pi over 2, we went up 1. And this is the unit circle, so that's how I know I'm going up 1 unit. Now, before I go on, I want to show you a little trick. It's kind of interesting. I'm going to take all of the signs, all of those fractions, and I'm going to make some of them into equivalent fractions, like 0. That is equivalent to the square root of 0 divided by 2. Okay. 1/2 is equivalent to the square root of 1 divided by 2. This one is the square root of 2 divided by 2. This one is the square root of 3 divided by 2. And this one is equivalent to the square root of 4 divided by 2. You notice the pattern?
Why is 0 divided by 2?
Well, it's 0.
I mean, yeah.
I made it look like that, so it's a pattern. Do you see the pattern?
Counting up.
You see how it starts at 0 and it's counting up square root of 1, square root of 2, square root of 3, square root of 4. So if you have forgotten things, you could possibly use that as a trick to help you remember it. Now, after I go from 0 to pi over 2, which is 0 to 90 degrees, as my angles keep getting bigger, this is now at 120 degrees or 2 pi over 3, as my angles are now getting bigger, what's happening to the y value? Is this one higher up than that one? No, it is shorter. This one is now square root of 3 over 2. Then what happens here? Square root of 2 over 2, then 1/2, then 0. So the y values were increasing all the way to 90 degrees, then they start decreasing. After 180 degrees, after pi, 7 pi over 6, the next one down, my y value is, that's negative 1/2. It's a 30-degree reference angle, and it is in the third quadrant. So this one, same as right above it, only it's negative. So negative square root of 2 over 2. Next one, negative square root of 3 over 2. And then this one down here at 270 degrees, or 3 pi over 2, that's negative 1. We're going down 1. And then I'm going to go ahead and fill in the rest of those. We've got negative square root of 3 over 2. Now we're starting to get closer to 0 again. Negative square root of 2 over 2, negative 1/2, and then 0. So all of those numbers are coming from the length of those blue lines that I drew in. That's where these numbers are coming from. It's the y value. All right, so let's do cosine. If you haven't filled out cosine, take a moment. If you haven't filled out cosine, we'll pause this. If you haven't filled out cosine yet, take a moment, fill that one out. And we're going to talk about the same thing that we just talked about. And we are trying to gain a deeper understanding for this now that you're in pre-calc. You did this stuff last year, too. You're in pre-calc, you're trying to get a deeper understanding. So those lines I wasn't drawing because I like making lines or thought it was pretty or it's like not important. I drew it because it is important. So as you're taking your notes, I encourage you to take your notes the way I modeled them. The pattern continues. So if you look at this side, the 1/2 square root of 2 over 2. Right. The pattern just repeats itself. So where would the lines be for cosine? Cosine is what? Oh, apparently this has been running the whole time. All right. Cosine is x. So I'm going to start here. I'm going to go over 1. All right, so the x value at 0 degrees is 1. The x value, how much do I go over at pi over 6? You can look at that. That's certainly less than 1, but it's not 1/2. It's that radical 3 over 2. At pi over 4, that should be the same as sine at that point. Radical 2 over 2, and that's because we memorized it. How about at pi over 3? That's the half. And then at pi over 2, 0. So we start out at 1, and then we're getting smaller to 0. And then what happens after we pass 0? We go to negative 1/2. Then we go to negative radical 2 over 2. Negative radical 3 over 2. And then from here we go negative 1. And that's the furthest left that we go. So from here we are going smaller, less negative. Negative square root of 3 over 2. And we go less than that. Or more positive. That would be negative square root of 2, square root of 2 over 2. Then we have negative 1/2. Then we have 0. Then we go the other direction, and we have now positive 1/2. And we have positive square root of 2 over 2. We have positive square root of 3 over 2. And then we get to positive 1 again. What would happen if I passed, I went all the way around, 360 degrees, 2 pi, all the way around, and then I went back to pi over 6? Would the answer be different? No, it would be the same. If I went all the way around, and then I went back to pi over 6, it would be the same cosine as just originally going to pi over 6. It's coterminal. And I'm in a circle. So this repeats itself over and over again. It keeps repeating. Look at cosine and sine side by side. Are they similar? What do you mean by just flipped?
Well, the first and fourth quadrant on the cosine one is the same as the first and second quadrant.
Okay, so how would I get sine? How would I take this picture for sine and translate it, not translate it, transform it? How would I change it so it becomes the cosine picture? You take sine, it looks like a steering wheel, driven? Which direction?
Right.
I'm going to turn it that way, 90 degrees, 90 degrees, right, 90 degrees, I'm going to turn my email. So I'm just going to turn it 90 degrees, and then it becomes that, exactly. So when we see these graphs, when we actually graph them on, and you've done this last year, when you graph the sine and cosine curves, they're going to look the same, they're just going to, one's going to be shifted 90 degrees. They're going to have all the same numbers. One's going to be shifted 90 degrees. Right. Let's look at transformations. That is there for you as reference. We've already covered that in this class, and it's from previous content. This was section 1.6 in our book, and section 1.6, will that be on your exam? So we're going to review that, but we're going to do it with sine and cosine today. We're going to review section 1.6 on your book. So yay, we can review. That's just formulas to help you remember what's what. For example, if we have a number out here after the main part of the function, we have a number on the outside that tells us that we're shifting that function up. But if the number right there is a minus sign, then we shift it down. Remember this stuff? If there is a negative outside, that's a reflect in the x-axis, that's a vertical reflection. If there is an actual number there, then that would be a stretch vertically or a shrink vertically, depending on if the number is greater than 1 or between 0 and 1. So this is all prior knowledge. This is vocabulary. At the very top, you might have seen this last year. Did you see this last year? Well, depending on which class you were in last year. These are exactly the same, one's sine, one's cosine. And you'll see that we have A, B, C, and D in there. Today's notes, we will be covering D and A. We will not be looking at B and C until Monday. So today we're talking about the A value and the D value. So here's the vocabulary that talks about them. A is always the amplitude. It says 1/2 the distance between the highest and lowest point. I'm going to tell you that this is the absolute value of the A. It is the absolute value of the A. So it is positive. It is also, well, greater than 0. Of course, if its absolute value is greater than 0, but it can't be equal to 0. I guess I could say that. So the amplitude is the A value, the absolute value of the A value. The period has to do with B, and we'll do that on Monday. But vocabulary-wise, you do have to answer questions about the period today. The period is, how far is one full cycle before we repeat ourselves? 2 pi. So you'll see in here there's a 2 pi, but then it says divide by B. We're not doing the divide by B yet. So today, your answer for period is always 2 pi. Got all of your answers, 12 questions right there. Answers, period is 2 pi. Phase shift is C, and that's going to shift it left or right, and we will do that on Monday. And then D is a vertical shift, and we will be doing that today. So it's going to shift it up or down. Use the warm-up problems to graph y equals sine x and y equals cosine x. So we're going to use the warm-up problem. We're going to find what the sine at 0, pi over 2, pi, 3 pi over 2, and 2 pi is. These are going to be called key points. So what do we start at? 0. So we're on the unit circle. Sine is y. We're starting at 0. What is y at 0? 0. Then it goes up to y goes all the way up to 1. Then it goes out to 0. Then it's all the way down at -1. Then it's back at 0. So we're looking at the y values. 0, 1, 0, -1, 0. Sine always starts at 0. Memorize those key points. Your job, memorize them. Sine starts at 0. Then when we go to graph it, the x value is the radian, and the y value is what sine is at that particular angle. And this first line is not exactly centered, and it bothers me, and it'll probably bother you too, if you're like me. So I'm graphing one period right here. This is one period. This is not the entire graph, because you're going to fill out the entire graph. This is one period. So to get the rest of the points, I just repeat the pattern. I'm just going to repeat that pattern. So I'm going to go up again, center, down, center. I'm just going to repeat that pattern the other direction. We'll go down and then center. So I'm just repeating that pattern. So you're going to draw one period and then repeat the pattern. There's my one period, and then I just repeat the pattern all the way through the graph. Why did, you can not, You can barely see it, but why did I put arrows? It goes on forever. So we have arrows telling everybody who looks at my graph that it goes on forever. So make sure you do the negatives also. All right, so now we're going to do the cosine. We need to first start with our key points. You guys remember doing this stuff last year?
Yeah.
See, I'll review. Cosine starts at 1, then it goes 0, -1, 0, 1. You graph them. Starts at 1, 0, -1, 0, 1. So the first thing that we notice about cosine is it kind of looks like a valley. That was not good. And then from there, it just repeats. So I'm just going to continue the pattern. Does it look like these? Does not look like these. Do not make it look like these. It is rounded and it takes practice. Yours looks like a V. A little bit.
Yeah, it does.
All right, so those are parent functions. And we're going to translate those, or transform those. So example 2, you'll see the word transformation at the bottom. Let's talk about the transformation first, just using the equation. Transformation, if we look at the equation, what's different about this equation compared to the parent function y equals sine x? What's different? There is a 2 in front. Yeah, what does the 2 do? That is a vertical stretch. And I said this earlier, but that 2, that gives us our amplitude, which is not asked for this question, but might as well practice our vocab. Amplitude gives us the amplitude. That tells us that it is stretched 2 above and 2 below the center line. So we fill out our table. I'm going to put my key points in, and sine starts at 0. And then 2 is that A, B, C, or D. That's the A value. So for A, I'm going to multiply everything by 2. But you see where A is located in the table, it is next to the Y values. So you multiply the Y values by 2, not the X. And then we aren't graphing this one, we'll graph the next ones, but when you go to graph them, you would graph the same X's, because we didn't change those at all, and you would graph the new Y values. That would be my XY. Do you remember which letters I told you we're doing today? We're doing A and D. So you'll notice that we're only doing the Y side today. I put this table in every single question, even though we're not using B and C today, but you will on Monday. Next question, sin x plus 2. What is that plus 2? What transformation? It is a translation. Translate. Okay, I just spelled that wrong. Up to units. Yes.
So if it were like if it were going to be like a horizontal shift, they put the difference.
It would be after sine with the x. If it was.
With the x sign plus 2.
No, I'm sorry. You were talking about a horizontal stretch or a horizontal shift? Yeah, there would be crunches if there's a horizontal shift. Yeah, but that's Monday. All right, so sine, that's 0, 1, 0, -1, 0, and then we do plus 2. That is my D column. So when you go to make your table, I didn't make a table for your homework. When you go to make your table, you wouldn't even have to draw the A column because we're not even using it. You just draw your X, your Y, and your D column. We just add 2. And then if you were to graph that, you would graph those two columns, the outside X and the outside Y column. Okay, this is a summary of what we just talked about, so if you need to go back and look at it later, you can. Let's try 3 more examples and then we'll work on our assignment. Graph y equals 3 cosine x. What does that 3 do? It stretches it. It's a what kind of stretch? This is a vertical stretch. So that we put in the A column. And this is cosine, and cosine starts at 1. We'll multiply everything by 3. All the y's by 3, I should say, not everything. And then we go to graph the x column and the times 3 column. That's what we graph. We'll go over it. We'll go over it. I'm going to introduce some vocabulary as we're doing these, and then the vocabulary you'll actually see on the next page. Please make sure, though, that you have the entire graph left to right filled out. I do not want one cycle. I don't want one period. I want to keep going until you've filled out the graph. So all you need to be able to follow the pattern. That's what I want to see, is that you can follow the pattern. And then this is not asked of this question, but let's start talking about what's the amplitude. The amplitude is 3. That is how far above and below the middle line. Where's the middle line? What is this middle line here? It is the x-axis, but can you give me an equation that makes that middle line? Not x equals y equals 0. So when we have y equals, that's saying that y is only at 0, x can be anything. So that you'll see on the last page, they refer to as the, I don't know if right, sinusoidal axis. That's what they call that. Okay. And then we have number 2. What does this negative do? Reflect in the x-axis, but that is in our A column. Is our amplitude -1?
No.
Because the amplitude is just a positive number. And so the amplitude would be 1. There's no stretch on it, there's just a reflection. It's just reflected, it's not stretched. Amplitude is a stretch. And then that 4 tells us to do what? So translate up 4 units. So that would do +4 in my D column. I've already told you we don't have B and C today, so no, they weren't over there. Key points, this is sine, so it starts at 0. And multiply by -1, and then add 4. Oops. Graph them, we start at 0, 4. then we go to 3, then we go to 4, then we go to 5, then we go to 4. So before I add in more points, I can see that my sine graph is just flipped. It doesn't go up first, it actually goes down first. It's just flipped. And it's also moved up 4. Then I will fill the rest of the pattern points. All right, so if I asked for the amplitude, we talked about that a second ago. What would be the amplitude for this one? All right, just 1. And then sinusoidal axis. That would be the center of the graph. Y equals 4. Now, both of those numbers come from the A and the D values. Both of those numbers, the 1 and the 4, come from the A and the D values. Okay, last example, you are answering period, amplitude, sinusoidal axis, domain and range, which we haven't talked about yet. We have in this class, just not about this kind. Graphing it and filling out a table. I'm going to give you a moment to try what you can on your own, then we'll fill the stuff in together. If you've already gotten it, you can, of course, start working on your assignment. All right, so filling out the table, I'm just going to start with the table. We're going to multiply by 2, and then we're going to subtract 3. Go ahead and do that real fast. And this is sines. I'm going to use my sine key points that start at 0. Multiply everything by 2. And then subtract 3 off of my previous step. And so we get the ordered pairs. The x's didn't change, and we're looking at our D column. 0, -3, then -1, then -3, then -5, -3. Sine has the same picture. It's this like roller coaster looking thing, the up down. Unless there was a reflection on it, then it would be down up. But it always has that same picture before you start repeating numbers. Okay, so my graph. I'm going to go ahead and fill out my information from that. Our period is 2 pi. We won't have any other answer for the period. That's just like how, from start to finish, how long is one cycle? It goes from 0 to 2 pi. That's 2 pi long. Amplitude, how far above and below the center does it go? By the way, it's the A value. 2. The sinusoidal axis is where is that center line now located? Since I shifted the whole thing down 3, it's y equals -3. Domain and range. Domain is what x values am I allowed to put in the x column. Now, we used key points, but you can choose anything. Right, -infinity to positive infinity. If I kept graphing this, this would go on forever left and on forever right. It would go forever. Range is the y values. What's the lowest y value? -5. And is it equal to -5? It is. So it is a bracket. Excellent. And then it goes all the way up to what number? And it goes continuously through those. It doesn't just jump. So then we can say it is an interval. Okay? So that's your assignment. You got 12 questions.